Hi, hello, good morning, one and all. Welcome to the session. Can anybody confirm about audio and video? Just give me a second so that we can move on to the session. ऑडियो वीडियो दोनों क्लियर है क्या? Hi, hello guys. Please try to share this session with your friends and colleagues so that they'll also get joined here. In this session, we are going to discuss about EMMC, electromagnet moving coil instrument. Let me recall for some time. Meanwhile, you can please do join in. In the last two sessions, we had a discussion on PMMC instrument. I think there is a lag is going on. Just give me a second. Let me check this one. Okay, no problem, no issues. We will try to discuss about this EMMC instrument. Please, somebody can confirm about audio and video. Let me check from my side. Okay, all right, so let's move on to the session. So we had a discussion on PMMC instrument, and then we had a discussion on EMI instrument, okay, in the last two sessions. In this session, we will be discussing about EMMC, electromagnet moving coil instrument. What I wanted to say is here, because of some drawbacks in PMMC instrument, we have gone through EMI instrument, and because of some drawback in the what I can say EMI instrument, we can move on to EMMC instrument. So the drawback of PMMC instrument is what? It reads only DC quantity. It reads only DC quantity or average quantities, I can say. Now to overcome this drawback, what we designed is moving error instrument, and the moving error instrument is going to read DC as well as AC. So that's the drawback of PMMC instrument is overcome by designing the EMI instrument. Now what is the drawback in EMI instrument? So why we move to EMMC instrument, right? These all instruments are for what? The instruments are to measure the current, voltage, power and energy, right? So these are the four quantities I need to measure in the electrical circuitry or electrical power system domain. Okay, so here I can measure current, I can measure voltage with the PMMC instrument, but I can measure only DC quantity. So that's the reason why to measure AC quantities as well as DC quantities, we have designed EMI instrument. Now when it comes to the power measurement, EMI instrument cannot measure power measurement because power has two quantities. It's a product of voltage and current, right? Now to measure voltage, we need one coil, and to measure current, we need one more coil. Right, if you see PMMC, there is one coil, only one coil, which is rectangular aluminum frame, and if you see EMI instrument, there is electromagnet, which is also only one coil. Okay, right, but if you want to measure power, one coil has to measure voltage and one coil has to measure current. So that means what? Meter should consist two coils in its construction. Then only you can able to measure, power. So that's the drawback of EMI instrument, and that is the reason why we are going for EMMC, electromagnet moving coil instrument. So electromagnet is one coil and moving coil is one coil, another coil, second coil, right? So this is electromagnet moving coil instrument is a combination of PMMC and EMI. Electromagnet is taken from moving iron and moving coil is taken from PMMC. Okay, so PMMC. So I can say that EMMC is a combination of PMMC plus moving iron instrument, right? So now, if you design EMMC instrument, what you need to measure? This EMMC instrument has to measure current, has to measure voltage and power, because PMMC can measure current and voltage, MI can measure current and voltage, right? Now, whatever the drawbacks these two meters have, and that drawback should not be there in this EMMC. That means it has to measure current, DC current, AC current, DC voltage, AC voltage, and the power also. So that's what you need to keep it in mind before you are going to design any instrument. So that's the right. So let us move on to the session. Before moving on to the session, I just wanted to tell you about myself. This is a small introduction about myself. My name is Naveen Gollapalli. I have 11 plus years of experience in teaching. Most of the times I'll be teaching electric circuits, machines, measurements and power systems. I did my masters in electrical power system from JNTU Hyderabad. I cracked GATE and State Public Service Commission examinations too, and I taught more than 20,000 students more since 2012. So this is a small introduction about myself. There is a small announcement from the BYJU'S exam prep platform that is about scholarship test. Okay, I'm sorry, today is 26th, no? So this is not updated. I think this scholarship test has done yesterday. So I think you can, if you want to write scholarship test, if you want to appear for scholarship test, there will be another scholarship test also, maybe probably next week or coming weekends. You can write them and get the discount up to 90%. The timings also will be mentioned, maybe 9 AM or 12 PM, like that they'll mention. So please follow the BYJU'S exam prep platform so that you can get an idea. Okay. So now let us move on to the topic here. If you see here, electromagnet moving coil instrument. So this is a rectangular aluminum former, and on this, what I said, this moving coil is taken from PMMC. Taken from PMMC means the origin for the root cause for the design of EMMC instrument is PMMC. So, and this is the electromagnet, which is same as the moving iron instrument electromagnet. So here on the rectangular aluminum frame or aluminum former, I will be placing the coil. This rectangular frame may not be aluminum, it can be some plastic also, it can be a lightweight material also, because it's a moving system now. So we need to design the moving system with as much as less weight. Then only when a torque is going to be produced on a moving system, it can easily move, it can easily deflect. So don't design the moving system with heavy weight or heavy mass or huge amount of mass, otherwise you will get a lot of frictional errors. Okay, so this is my moving coil and this is my moving coil. So this moving coil and here electromagnet, I can call it as fixed coil or electromagnet. Okay, which is taken from MI instrument. So this fixed coil actually made into two equal halves. So this is a half fixed coil and this is one more half fixed coil. Okay, or you can call it as fixed coil 1, fixed coil 2. Okay, now you need to, if you want to measure current how do you connect these two coils? If you want to measure voltage, how do you connect these coils? To measure current or voltage, you need to connect these coils in series simply. So take this fixed coil connection. The finishing end can be connected here, and then okay, so let me show you here. The connection is not proper. Probably you can take up yeah, let me take up like this. Here now the circuit can be like this. If the circuit is like this, R1 R2. Now if you want to measure the voltage across R2, now connect these terminals at this point. That's it. So this is going to behave like an voltmeter, and if you connect this meter in series with the R1 and R2, then that is going to measure current. That's it. All right. So here there are some names for this 4 terminals. Okay, right, I'll give you those names also, but I just wanted to add one more point at this moment, that is half of this fixed coil and half of the other fixed coil are connected in series, and then that is also connected in series with the moving coil. So altogether, even though it has 2 coils, even though the meter has 2 coils, it is again now only 1 coil, so it can measure current, or otherwise it can measure voltage. So current measurement or voltage measurement is possible at this moment. Okay, is it clear for everyone? Good morning, Ashok, how are you? Now see, that is what the connection I have shown in the last slide. Try to observe. See, this fixed coil, half of the fixed coil is connected with another half of the fixed coil in series, and then later the moving coil is connected in series like this. Now you take this combination and connect across any element, that will give you voltage. You take this combination and connect in series with any elements, so that will give you the current. Okay, so this will give you current or voltage measurement. Okay, now the question is the drawback of PMMC instrument, the drawback of EMI instrument has to be overcome. So the drawback of EMI instrument is what? It cannot measure power, right? So whatever we design, the next instrument, whatever the next instrument we are going to design, that has to overcome the drawback of previous instrument. So now by using this construction, we have to measure power measurement also. So now is it possible to measure the power measurement or not? That's what we need to see. Let's check that one. So I have one more diagram here. Now to measure the power, we need to measure the voltage across the load. We need to measure the current through particular element, because wherever you want to measure the power, that element voltage, that element current, you need to consider. So to consider that, you see here, this is the starting terminal, and it is I can take up it as main terminal, and the electromagnet finishing terminal is connected to next half of the electromagnet, and this is my L terminal. You can take up it as load terminal. And this is where I can connect the load. This is where I can connect the load. Okay. Now see, please try to understand, there are some beautiful questions, there are some fundamental questions. The fixed coils are connected in series with the load. So that means what? Fixed coils are going to measure current, or they are working as current measuring coils. That's why we call them as current coils. So it measures load current, right? Now I need to measure one more quantity, that is load voltage. So this is going to measure current of the load. So fixed coil are going to measure current of the load. Now moving coil. So this is my moving coil. The top one you can see the spring, and below that one I have a moving coil. So let me take up this end and this end like this. Now how should I connect this? Is a question. Okay. Now you need to measure the voltage across the load. So you can connect this terminal at the load end, or otherwise you can connect this terminal at the source end. So generally, if you connect this terminal at this end, this terminal we call it as C terminal, and this terminal we call it as V terminal, and connect this to neutral of the supply terminals. Now if you can see, so the supply, and this is the moving coil, and the moving coil is going to measure the voltage of the load as well as the current coil too. If you connect like this, okay. If you connect like this, let us connect in another manner. If you connect this V terminal on the L point and C terminal on this point, or otherwise you can connect the other way also. Let me make this as C terminal and connect this to L, and let me make up this as V, connect this to here. Now if you connect this one, this moving coil is going to measure the voltage across only load. Okay, it is like just same as like voltmeter ammeter method and ammeter voltmeter method connections. So here the moving coil is useful to measure the load voltage, whether you connect, whether you make it as LC short or whether you make it as MC short, it is going to measure load voltage, majorly load voltage. Here the moving coil is used to measure the voltage, and that's the reason why it is called as voltage coil or pressure coil. Voltage coil or pressure coil. Okay, so there are some two questions, beautiful questions on this moving coil and pressure coil. We will discuss those questions in the app after 11:45. Okay, so in this session we will discuss about the operation of EMMC instrument, and let me show you the internal parts of the EMMC wattmeter. Okay, are you ready, guys? Let me hide myself so that you can watch it completely. So this is my electromagnet moving coil instrument. You see the scale at the beginning, scale at the end is cramped or compressed. Now I just remove the glass. Now you can see here, this is the scale, and then if I open that scale, and this is the construction, the beautiful construction of the top view, and let me show you the side view also. So the side view, you see we have got here how many terminals? 2 coils are there, no? 2 coils. So each coil will be having 2 terminals. So 2 into 2, you will be getting 4 terminals. Terminals should be 4 terminals, right? So see there will be 4 terminals. Terminal 1, 2, 3, 4. It's like starting and finishing end. If a coil is there, every coil will be having this is 1, 2, and another coil if you have 1, 2. So there will be 4 terminals. I have fixed coil and I have moving coil. So because of 2 coils, I will be getting 4 terminals. All right. Now see the other side. Here. Let me show you with the highlighter or laser point. This side is an electromagnet, half fixed coil, and the other side is also half fixed coil. You see, this is a half of the fixed coil and this is half of the fixed coil, and they will be connected in series. Okay, it is also in your hands. It's like when it comes to range extension, current coils can be, that fixed coils can be connected in series, can be connected in parallel. On the wattmeter, you will be having some steel terminals. If you connect them in horizontal manner, the current coil will be in one connection. If you connect them in vertical manner, the current coil will be in another connection. Okay, all right. So those are that will give you the range extension for the current coils. Okay, so this is half of the fixed coil and this is another half of the fixed coil, and in between that you have a moving coil. Okay, now we will come across this resistor part and this element also, but see, try to observe. Here it is the spring, and above that we have a pointer. Okay, are you able to see? Another side view of these EMMC instrument. You see the spring, Okay, we will see the connection diagram also and see the middle, the moving part. Let me hide myself so that you can see the moving part clearly. So this is the moving part. There is a moving part. Okay, if you want to see it, let me show you from my side also. I have the moving EMMC instrument. Let me show you from my side. It's like this. I think you are able to find this one. So this is an element. We are going to discuss about this one, this element also. And here I have got some resistor and the 4 terminals. And what I wanted to say is, you see, when I touch the pointer, you see the inside moving part is moving. So the moving part is not supported on aluminum former, unlike PMMC instrument. On the PMMC instrument, if you see, we have a rectangular aluminum former. On that we will be winding the coil, moving coil. But this moving coil is not having any support. The support is hardly a layer of plastic. Okay, have you seen that? And then moving on to the other next one. So this is the main terminal, line terminal or load terminal, and the common terminal and the V terminal. Just now we have discussed. Okay, right. Now if you see this one, clearly, try to watch it clearly. This is my M and this is my L and this is my C and this is my V. Let me hide myself so that you can see clearly. So let me show you the connection diagram. So this is the half of the fixed coil and this is the another half of the fixed coil. So FC1 and FC2, and in between them I have a moving coil. So let me show you the moving coil here. So this is my moving coil. All right, the moving coil is useful to measure the current voltage, and the fixed coil is useful to measure the current, so we can call them as current coils. So here this is the M terminal and this is the L terminal. This is C terminal and this is V terminal. Now what is there? Let me show you. So we are going to connect a phase terminal here. And then the fixed coil finishing terminal and the fixed coil starting terminal of next half, we are going to connect them in series. So they are connected internally. And then the L terminal is available here. Now what we do is we take up this out and connect it to load. So we will take up this and we will connect it to load. Okay. So this is my neutral. This is my phase. And we left out with current C terminal and V terminal. Now it is your wish to join the M and C or L and C. So if I join with the M and C, this is MC short. Okay. Now in series with the C terminal there is a resistance. And in series with the resistance there is another element. So it's like there is a resistor and another element, a bigger element in series with that C. Okay. Now C, and of course, and then later I have a moving coil to say exactly. Okay, whatever we can see here, let me show you a resistor and a big element, and then I have a moving coil. Okay, so this entire connection is going to be on the other side here, right? Okay, you can see may not be clear from in this one. So this is my finishing terminal of moving coil, that is V, and it is connected here. Now my question is what is this element? My question is, what is this element? Can anybody tell me? Can anybody tell me what is that element? Generally, fixed coils are going to be designed with least number of turns. Why? Already we will be having some load, and this load will be having some impedance, and if you add some more and more coils, that coil impedance also going to be added to the load. So actually we should measure only the voltage across load and current through the load. Because of extra number of turns in the fixed coil, that impedance also going to be added, and the load current is going to be minimized, and moreover load impedance is going to be changed. So what we do is we generally keep the fixed coil or current coil turns as very least. That is one point. If you keep more number of turns, more amount of drop takes place, and that drop will be added into the load. So in order to minimize the drop, we generally fix the current coils with least number of turns, but area of cross section is very high. So the current coil resistance is least, but area of cross section is very high, and the length of the current coil is also going to be least, but area of cross section of the current coil is high. Okay, and then if this is my M terminal, now this moving coil, every coil will be having some resistance and reactance nature. So when it comes to current coil, very least reactance and very least resistance, because they are not having many turns. And when it comes to moving coil, I'll be having the pressure coil, and I'll be having the pressure coil resistance and pressure coil reactance. Okay, this is the coil resistance and reactance. Along with this one, we are connecting an extra resistance here, and we are connecting an extra element here. So that is to say exactly compensating resistors. To compensate or to dominate the inductive reactance of the moving coil, we are going to place a large resistive coil. A large resistance. This is a large resistance. It is not a capacitor. It is not a capacitor. It is a resistance. Very good, Ashok. It is not at all a capacitor. It is a resistor of high value. Why? To dominate this inductive reactance. To dominate the inductive reactance, and therefore that's why we say the pressure coil of wattmeter is made highly resistive, so that the error due to inductive reactance can be minimized. Error due to inductive reactance can be minimized. So that's the point. Still, if you want to eliminate the error, due to inductive reactance, we will keep capacitor. So in this instrument, we do not have a capacitor at all in this range. Okay, this is not a capacitor, this is a high value of resistor. Okay, keep that in mind. So the operation is going to be simple. So whenever you give the supply, that supply is going to drive a current, and that current is going to be divided as ICC and IPC. ICC is going to give you one flux, and IPC is also going to give you one more flux. I can take up this as phi 1 and phi 2, and the interaction of these two is going to give you the deflection torque. So the deflection torque moves the pointer and the spring. So when the spring compresses, then you will get TD and TC, and therefore you will get a steady state operation. The TD is directly going to give you the power measurement. Okay, so voltage across the pressure coil, current flowing through current coil, and cos of angle between VPC and ICC. It looks like power factor angle only. Simple. Okay. Now the point we will discuss some questions on this electromagnet moving coil instrument construction, and especially construction based questions are there, very beautiful questions. So please try to join on BYJU'S exam prep app. You can find the link in the description, or else I'll post the link also in the comment section. So please try to move on to the app section. Okay, so now here I'm going to turn off my video for some time, and once I start this one, what I can say, app session, you can join there. So please come on to the app session, guys. Ashok, we will discuss about power factor meter also, no doubt, no problem. The thing is, I don't have the meter to show you, that's the reason. But I'll you know, if you have, if you get an idea about the, what I can say, this one, it's not a big deal to understand the power factor meter.